really not. Okay, let's talk about this worksheet, 3 forms of graphing quadratics. Again, this is what I had handed out. So let's throw together 1, 2, and 3 on the same grid. And we'll do it graph next. Finish. All right, so problem number 1, we have this. So let's just find the vertex. Negative b over 2a, our b value is 0, so negative b over 2a would result in what? 0. Okay? So 0 is for my x component of my vertex. Plug 0 in, 2 times 0 squared minus 8 becomes 0, negative 8. And this grows at a rate of not 135, but 269. Sweet. I'm going to go right 1 up 2, left 1 up 2. And then 1, 2, 3, 4, 5, 6. And that should be enough for us. Let's see. Axis of symmetry of this problem, x equals 0. Okay, it's the x component of the vertex. The vertex is 0, negative 8. And the y-intercept happens to be where the vertex is in this case. So that answered those questions. And then problem number 2, we'll draw it on the same grid. Number 2, we have f of x is equal to x squared minus 2x plus 2. So I can use my negative b over 2a, which gives me negative 2 over 2 times 1, right? So negative 2 is positive 2 over 2. So that gives me a 1, right? Did I do that right? And then my vertex, I get 1 squared minus 2 times 1 plus 2. So 1 squared is 1. Negative 2 times 1 is negative 2. So 1 minus 2 is negative 1. Negative 1 plus 2 is 1. So my vertex is 1, 1. Okay. This is growing at a rate 1 to 1, or 135. So I'm going to go, that works, and then right 1 up, 1, 2, 3. Left 1, 1, 2, 3. So the axis of symmetry of this problem is x equals 1. And then the vertex is 1, 1. And the y-intercept on this case is 0, 2. Does that make sense if I said it that way? And again, we're going quickly on these because we learned the schematics of it. Problem number 3 is going to be down on the same graph. This is already in vertex form for us, agree? So what is my vertex? 5, 2, good. Okay, remember it's opposite value inside, same value outside. So 5, 2, 1, 2, 3, 4, 5, up 2, putting a dot. The negative 2 out in the very front means it's going to go downward, and it's not going to grow at 135, it's going to grow at, there you go, negative 2. So I'm going to go right 1 down 2, left down 2, and then I'll go right 1 down 6. 5, 6, left 1 down 6. That's what that graph looks like. So my axis of symmetry is x equals 5. My vertex is 5, 2. And my y-intercept on this particular problem, anyone want to get that far? So on this problem, in order to figure out your y-intercept, you'd have to go x minus 5 times x minus 5. So if you were to multiply that whole thing out, you get x squared minus 5x minus 5x plus 25 times the negative 2. So that's negative 50 plus 2. So my y-intercept is at 0, negative 48. So way down yonder. Again, I didn't really multiply this whole thing out. I just realized what this last term is multiplied together. Multiply that last term times that, and then add the 2 to it. So that's a little different way to do it. If you don't see it that way, multiply the whole thing out, distribute the -2 over it, and then combine the +2, and then your C term of your standard equation will be your y-intercept. That's the first three. Look good? Can I go to a different board? Again, it's being recorded if you need to catch up with it. So take a look at the video that'll be up tonight. While I'm switching to the next board and getting things set up, we will have I have a Schoology that I'm going to put up. I meant to put it up last night. I'll put it up today. And it's a little bit bigger. It's due Friday of next week, and it's worth 30 points. Friday of next week is the Friday right before spring break. I have it as resumable, so you can do a little bit of it at a time, and then come back to it when you need to. But it's 30 points this time versus 10. Yeah. It's 9 or 10. Okay. You're going to get on to it's only 7 questions. Wow. I lied. I'm sorry. Yeah.
How many tries do you get?
3. So go through the luck of the draw. Submit it first time. Oh, shoot. I got a 61%. So then try it again. And I think I have the matching ones. Before I publish it, I will make sure that partial credit comes. Because some of you,
yeah, I got like a 9.
now it should work. Double check it now. I bet you it works out. Yeah, I'm sorry. I forget to hit the one little thing, getting allow partial credit. I apologize.
Oh yeah.
I usually have that. Like you do like if you get like one wrong, you'll be like 0 out of 10.
Right. So now it is allowing partial credit.
Okay.
So like if there was like 6 choices that worked, and you guessed 5 of them, you're gonna get 5 out of the 6.
Okay.
5/6 of the 10 points.
Yeah, that was kind of crazy.
So I apologize. I went back and I recorrected it, so I think it's all correct now.
I can go back and
No, I think it's now corrected. I think it auto-corrected itself. Does that make sense?
yeah.
So, but if you need to, you're always welcome to double check my grade book versus what Schoology is saying you're getting. Let me know if it's a discrepancy. If it is, I'm sorry, I switch it. All right, 4, 5, 6. Number 4. Oh, come on. Number 4. Hey, this one's y equals. This one's y equals. The other one was f at x. F at x is functional notation. Y equals is just y equals. They mean for the most part the exact same thing. So if you see function at x, it's the same thing as y. This one's a little different than the ones we'd worked on. This one tells us where it crosses the x-axis. Okay, this tells us the x-axis crossing pretty easily. If you set each of these equal to 0 and solved each of these, you would find that you'd get +3 and -1. But that's not the vertex. That's just where it crosses the x-axis. Agreed? Now the vertex, you have to understand, is halfway between these. So if I come in, looks like right about here, the vertex is going to happen at 1, something. How do you find the vertex? Where should I plug that x equals 1 into? Back into the original. Okay? Because this is y equals. So if I plug this back in, I get 1 minus 3, which is -2. 1 plus 1, which is +2. -2 and +2 multiplied together give me -4. So I get 1, -4, which is down here. This would grow at a rate of 1 to 1, so I can go right 1, up 1, left 1, up 1. To get that. Does that make sense?
Yeah.
So our axis of symmetry is x equals 1. Our vertex is 1, -4. And our y-intercept looks like, where's that y-intercept? Where? 0, -3. Right? Sweet. All right. Number 5. Now it's back to functional notation, which that means the same thing as what? Y, okay? And we get 2x squared plus 8x plus 6. Now some of you might look at this saying, hey, I have a greatest common factor. You're right. Okay? It does have a greatest common factor of 2. So we could go through that way. Or I could just do the vertex way. So I get negative b over 2a. So negative b is negative 8 over 2a is, what's a?
2.
So 2 times 2 is 4. So negative 8 over 4 is the same thing as what number? Negative 2. Good. Now this is where you got to be cautious. I'm plugging a negative here and a negative here. What is negative 2 squared? Positive 4. Positive 4 times 2 is 8. So I'll make that an 8 plus negative 16 plus 6. So 8 minus 16, negative 8. Negative 8 plus 6, negative 2. So negative 2 is where this one exists right there. It's growing at a rate twice as fast. So it's not 1, 3, 5. It's 2, 6, 10. So I'm going to go right one up 2. Left one up 2, right one up 6,
Yes.
6, left one up 6. So my axis of symmetry is x equals negative 2 because the x component of the vertex. My vertex is negative 2, negative 2. And where it crosses the y-axis is the point 0, comma 6. Number 6 is already in vertex form. It's y equals. Y equals is the same thing as f at x. Okay, so one's just in functional notation, one's not. What's my vertex here? There. Why is it negative 2? It's opposite inside, same outside, so it's opposite inside. So negative 2, negative 1, which is going to be about here. It's grown at a rate of 1 to 1, so right 1, up 1, left 1, up 1, right 1, up 3, left 1, up 3. So my axis symmetry is x equals negative 2. My vertex is negative 2 comma negative 1. And my y-intercept appears to be 0, 3, I think. Nice and neat, nice and neat. And I'm going to hit 7, 8, and 9, and then we'll call it good. Is that all right? And if you want to go over the others, just let me know, and I'll cover those for you. Insert, graph, Cartesian. All right. Number 7. Y. Oh, it's back to y equals, and that's the same thing as f at x, right?
Yeah.
Yeah, baby. If I wanted to find my vertex, I go negative b over 2a, but my b value is what? 0. So what is my x component of my vertex? Got to be 0. If I plug 0 back in, I get negative 0 squared, which is negative 0. Negative 0 is just 0. 0 plus 4 is 4. So 0, 4. 0, 4 is my vertex. Does it open up or down?
Down.
Down. And it grows at a rate of negative 1, negative 3, negative 5. So right 1, down 1. Left 1, down 1. Right 2, 1, down 3. Down 3. Sweet. That should be enough. My axis of symmetry is x equals 0. It's the x component of the vertex every time. My vertex is 0, 4. Where does it cross the y-axis? Also at 0, 4. Cool. Number 8. People slamming doors over there, man. Darn math, I hate you. This one's in vertex form already. What's my vertex? 3, negative 1. Perfect. Always opposite inside, same outside. Love it. Okay, so 3, negative 1. So 1, 2, 3, negative 1. It grows twice as fast. So what? 2, 6, 10. Good. So right 1 up 2. Left 1 up 2. And then up 6. 1, 1, 2, 3, 6. Left 1 up 6. Row, righty. Okay, my axis of symmetry is x equals 3. My vertex is 3 comma negative 1. Where does it cross my y-axis? Up there someplace. How do I know where? Well, I could multiply this whole thing out. I can go x minus 3 times x minus 3, FOIL it out. The last terms on negative 3 times negative 3 are positive 9. Positive 9 times 2, 18. 18 minus 1, 17. So at 0, 17, it will cross up there. Number 9. This one is already set up to tell us where it crosses the x-axis. Where does it appear? How do I know where it crosses the x-axis?
Crosses x or 3.
3 and negative 3. Set each of these. X plus 3 equals 0. X minus 3 equals 0. Ignore the negative out front. That just means it's going to open downward. So it's going to cross at negative 3 and at positive 3. Okay? My vertex is halfway in between. What number is between positive 3 and negative 3? 0. So my x component of my vertex is 0. If I plug 0 in, 0 plus 3 is 3. 0 minus 3 is negative 3. 3 times negative 3 is negative 9. Negative 9 times negative makes it a positive 9. So 0, 9. Okay? It's growing at a rate that's negative 1, negative 3, negative 5. So I'm going to go right 1, down 1, left 1, down 1, right 1, down 3, left 1, down 3, and then I guess I go right 1, down 5, 3, 4. Oh, sweet!
You have just done that over one down and then
Yeah. I was just showing that those existed. Yeah, I happen to work on this one, that the factored form where it crosses the x-axis. So my axis symmetry, x equals 0. My vertex, 0, 9. Where does it cross the y-axis? 0, 9 as well. 0, 9 could be the vertex. So the last three, if you have questions on those still, talk to me and we'll make it right with you, okay? All right, I have a note sheet, and I want to go over with you guys. Now, I'm going to tell you, this looks a little more complex, but it's not. And I bet you you're going to get the basic understanding. So if you need to, I need 15 good minutes. Andrew, I'll put one more, put it up, Casey. So if you need to stretch, need to poke your neighbor in the eye, you need to burp out loud, go for it. I can't count. How you doing, Georgie? Yep. God bless you. Thank you.
Yeah. Either way, you die.
Nobody dies. Okay, you guys ready? Y'all ready for this? So, take a look at your graph. Your graph looks similar to mine, but see how yours is numbered and mine is numbered. So yours is numbered going half, 1, 1.5, 2, 2.5, 3. You see that?
Yeah.
Okay. So can you make that replicate what I did up there? So each one of your little tick marks is actually a half mark. that make sense? Angela, you with me on that?
Yeah.
So the blue one I have up there is going to be our parent function. Okay? So, letter A, this is the most complex thing, but you're going to get it. So function of x minus 3. Now this is one of those, you can just throw this at you. This is classic ACT, SAT type of stuff. Ready to see how easy this is?
Yes.
Okay, if I had x minus 3 in parentheses on my problem, does that mean I shift right or left or up or down?
Oh, no. Left.
Which way am I going to shift if it's x minus 3?
Left.
It's always opposite inside, right?
Oh, no.
Right? You remember that?
Right.
So I'm going to shift right. How many?
3.
3. All right, ready? Eyes up here. Eyes up here. With me? I'm going to shift right 3. Are there like 5 points up there that I know?
Yes.
So where does this point shift to?
Oh, it's 0.
See how I shifted right? 1, 2, 3. This one's also going to shift right 3. 1, 2, 3. Still with me? This one also shifts right 3. 1, 2, 3. This one also shifts right 3. 1, 2, 3. This one also shifts right 3. 1, 2, 3. So, if something is in parentheses, it shifts the opposite of direction of what inside says. So, because that's x minus 3, it means I'm going to shift right 3. So I identify whatever points I can see, and I shift those points. I don't move them up or down. I just happen to shift it to the right. Everyone with me still? Seem okay? Okay. Letter B says f at x what? Plus 2. Is that plus 2 in the parentheses or not? No. That means it's not going to shift right or left. It's going to shift which way? Up. Which way is it going to go? Up. How many? 2. What's my parent function? Which color?
Blue.
Blue. Okay, so I'm going to take every of those points. I'm going to shift it up 2. 1, 2. This one shifts 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 up 2. 1, 2. Are we? Oh, this. Sorry. This one. 1, 2. Right? That make sense?
You missed that shift.
Sorry. It's recorded. Sorry. Might have to go edit that. Oh, jeez. I forgot to put the F on shift. So I shift 2. Sorry. Now it's on video, so you can show your parents, look, my teacher cusses. Sorry, if you're offended, I apologize.
My mommy doesn't like
Oh boy. All right. Let's see. What else can we do here? Letter C says what?
F at x, or no, negative f x.
Ooh. Negative f at x. Okay. Let's see. What happened? What happened on this one? I have negative function at x. So it's not going to shift up or down. Yeah, sleigh bells going?
It's Christmas.
Oh. Okay. A negative out in front. Negative out in front. That means, oh, I know what this means. This is going to make it's going to, so let's see how many. all x values change signs. All x values change signs. Okay, so on my blue, I have 0, 0. So we're going to change the x value. Negative 0, 0. What's negative 0, 0? Yeah, this is 0, 0. Okay, wait a minute. All right, hang on. All right, so now let's look at the 1, 1. 1, 1. All the x values change. 1, 1, that's x, y. So I'm going to get negative 1, 1. Oh, that goes over there. That's easy. Okay, oh, and then I have negative 1, 1, which is going to become 1, 1. Ah, look at that. And then this one, rather than being 2, 4, it's going to be negative 2, 4. And then negative 2, 4 becomes 2, 4. Oh, wait a minute. Why? Wait a minute. The red and the blue are the exact same. Oh, wait a minute. How can we make this work? I bet you this one was special because it was symmetric about the y-axis, which means, and this is a term that, God bless you, this is a term that you're not going to hear for a few years, but I'm going to use it anyhow. The blue parent function is something that's called an even function. It means it's symmetric about the x and the y-axis. And so an even function, when you shift over doing the opposite of it, they match up exactly. Not all parabolas are even functions. Like on this problem here, if this black problem was our parent function and I had the negative f of x, this becomes here. This becomes negative 4, 1. This becomes negative 2, 1. This becomes negative 5, 4. So if this one, it would rotate, flip over. So because the parent function was already symmetric about the y-axis, you can't see the negative of it take place. Okay? But we just have to know the negative out in front changes all x values to the opposite sign of what they already were. Okay? And again, because our parent function was already on symmetric about the y-axis, you can't see it as clearly. Okay?
So whenever it's negative, at x will always be the same as
Okay, if you ever have a negative sitting out in front, ready, Mac? Negative sitting out in front like we have on that one, means all of our ordered pairs, the x value sign switches. Okay? And it really is that easy. Okay, can I clear this off and we'll do the next set? We're still there? Okay. We go here. Let's go here. View, insert. We're going to do a graph Cartesian. Yes. All right. Here we go. All right, so let's put our parent function back on. So this one, our parent function is going to be red. And again, remember the parent function is the most basic form of it. Okay? But then we're going to go to letter D. Letter D. And that is f at negative x. Uh-oh.
Oh, I know.
F at negative x. Huh. Our parent function is just this. This is our equation. So that's what our parent function is right now. Okay, hang on. I think we can figure this out. So what f at negative x means is I'm going to replace any x's in our problem with negative x. So this means I'm going to, f at negative x means I'm going to go negative x squared. Not to be confused with negative x squared. The negative x is in parentheses because I'm plugging it in. What is negative x squared the same as? God bless you. What is negative x squared the same thing as? X squared. So this is the same thing as x squared. Well, that's dumb. That means on this particular problem, it worked out. Okay? But what if our parent function wasn't? So that means that our parent function and f at negative is going to be the same thing. So what this actually will do, I get that. You know what? I want to hold off on this one for a second, and I'll have a different parent function up there, and we'll figure it out from there. Is that okay? But we can get to it. But I'll come back to that one. Is that all right? Okay, so I'm putting an asterisk. We're coming back to D. Letter E. Oh yeah. Let's change colors. Letter E. We have 2f at x. 2f at x. Oh, you know what that does? This doubles all y values. If it was a 3x, it would triple all y values. If it was a 4x, it would quadruple it. Okay? So what's I have 0, 0. What's my y value doubled? 0, 0. Okay? If I go here, 1, 1, my y value doubled makes it 1, 2. Negative 1, 1, my y value doubled is here. Okay? Hang on. Right here. 2, 4, my y value doubled is 2, 8. And negative 2, 8. Oh. So this just stretches it. It's like the 135 doubled. 2, 6, 10. Okay, we do that. All right. Again, we're coming back to D, so don't worry, we'll come back to this. I have a different way to work it. I think it'll help us out on the graph below, I think. Letter F. Letter F. F at x plus 2 minus 1. Okay, go back and look at letter A. What did x minus 3 in parentheses do to our graph? So what values changed? What did x minus 3 do to our graph? Did it shift it right or left or up and down? Right or left. So x minus 3 shifted it right 3. This one's x plus 2. It's going to shift it left 2. What does the negative 1 do?
Move it down.
Moves it down. Ready? Parent function is the red one. Still with me? So I am going to, this point here, I'm going to shift it left 2 and down 1. There's my vertex. This point I'm going to shift 2, 1, 2, down 1. This point I'm going to shift 2, 1, 2, down 1. This point I'm going to shift 2, 1, 2, down 1. This point, shift 2, down 1. Shift FT left 2 and did I spell it right? Down. My teacher was cussing today. He didn't know how to spell shift. Oh boy. Okay, so I think I kind of made sense of this. I think. But I think we can make it work. Do we have 11 minutes left in us? Sure? Anyone need to scream out loud or anything? There's that one kid. Okay. Can I move down to the bottom graph? Can I go down to the bottom ones?
Yes.
Here we go. Insert. Graph. Next. Finish. Okay. All right. -5. 5, 1. And then 2, 1. Okay. I have no idea what this equation would be, but that's what it looks like. So let's see if we can figure this out. I think we could do it. All right. If I had f at x minus 2, it's going to shift which way? Right. How many? 2. Okay. Ready? If I shift right 2. Ready? Here we go. 1, 2. Done. What does this one do? 1, 2. Good. 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 All right. So this one does this as our little cup there. So shift to right. Okay. Now let's do this. Undo, 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 undo. Someone says, hey, go back, go watch the video. Okay. Next one. Going to the right, f at x plus 2. What does this one appear to do? It's going to go up. Okay? So this point is going to go up 2. 1, 2. This point's going to go up 2. 1, 2. This point's going to go up 2. 1, 2. This point's going to go up 2. 1, 2. This point's going to go up 2. 1, 2. Does that make sense? Okay. Ready? We gotta clear these. Clear, 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 clear. Okay. Green. So we're down below. Ooh, f at negative x. Okay. Look at your notes. What did I say this did? Switch what?
All the x values.
All the x values switch. Okay? Change signs on x values. So if it's positive, it becomes negative. If it's negative, it becomes positive for the x values only. If it's 0, it doesn't change because 0 doesn't change much. Okay. All right. So this point right here is negative 5, 1. If I change the x value alone, what's this point going to become? Negative 5, 1. The x values change. 5, what? 5, 1. There we go. Okay, this point is negative 2, 1. What does it change to? 2, 1. There we go. Okay, this point here is negative 1, negative 1, 1, 1. So negative 1 is here. And then this one switches to here. What does this one do? It goes from 2, negative 1 to what? There you go. Negative 2. So our graph looks like this. Here, down, there. Oh, it just flipped it over in this case. So all of the signs on my x points switched signs. Oh, this is so cool. I think I get this. Okay. Okay, can I clear? Okay, so again, it's still recording. So we have good stuff. So undo, 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 undo. All that work for nothing. Okay. Okay. Purple. Negative f at x. What did I say this was? Oh, was this the one that I needed to go back and redo?
Yeah.
Okay. This is what this one's going to do. Change all y values to opposite. Okay, again, we have these ordered pairs we know. So my ordered pairs are going to change. If they're a positive y value, it's going to become a negative. So this is the point negative 5, 1. If I change only the y value, negative 5, 1 becomes what? Negative 5, negative 1. Very good. If I change this from negative 2, 1, it becomes negative 2, 1, changes to what? Negative 2, negative 1. If this point changes from negative 1, it becomes negative 1, 1. If this point changes from 1, negative 1, I get 1, 1. But this point changes from 2, negative 1 to 2, 1. Here, here. Oh, cool. Am I almost done? Really? Oh boy, I'm excited. Okay. Can I clear those? Get this off the board before Ben can look at it. Nope. It'll be at about 41 minutes in, 40 minutes into the video. You can see. All right. Let's change some colors. Ooh, yellow. Yeah. Okay. Cool. Oh. Can we go with it?
No, do dash is pink. Dash is pink.
Use like
Or lime green.
Oh, we do aqua. All right.
Red.
F at minus 3. F at x minus 3 minus 3. Oh my goodness. Okay. So, hi. This is going to shift right 3 and down 3. Ready? Shift right 3. 1, 2, wait. Shift right 3. 1, 2, 3, and down 3. 1, 2, 3. Right 3. 1, 2, 3. Down 3. Right 3. 1, 2, 3. Down 3. 1, 2, 3. Oh. Oh, so cool. Oh my goodness. All right. All right. You ready? Y'all ready for this? All right. Your homework is page 67, 68. 67, 68. Looks like that. Oh, you guys rock this today. Oh my goodness.